8 hours, so somewhere around 9:20. And when does he have to leave by? I'm just going to move my cursor over here. He has to leave by 14. Yep.
Why couldn't you enter it 2.6.5?
Here?
Yeah.
If this represents when the water is below 13.
Okay.
Right? So if he's in the harbor, he's got to leave by then. Not in the harbor, he can only come in during this time when it's above that 13 meters.
Okay, thank you.
9.38, 14.6. So now we don't tell time with decimals, we tell time with minutes. So 9 plus 9 hours and times 0.38 by 60 gives you time, the actual minutes that he can come in. That was very good, 22 minutes. So he can enter at 9 hours, 22 minutes. So 9:22. So all I'm doing is I'm taking the decimal and taking that decimal and turning it into minutes. And I would do the same thing for the 14. What is military time? What is 14 hours? Yeah. 2 p.m. So we're looking at about 2:35, 2:40 for this one. This is in the morning, AM. This is in PM. So I know questions that you guys can all use your graphic calculator to do is the biggest concern that we have is how do I get that window? Well, in trade you get that window by figuring out periods and range. Okay, so we'll look at what we want to look at for the period. I like to always put two windows in, or 2 periods in, just because I want to see what the graph looks like, although that's not required. Wheel questions are probably one of the most common type of questions that you're going to see. Ferris wheels and other things. They've started throwing some really weird ones at us. We have a Ferris wheel. Now this is an example of cyclic motion. Because a person starts here, comes back down, goes around, and so forth. So the person's position on the Ferris wheel is a good example of a sinusoidal function. Okay. We have a passenger aboard the wheel, so we have a 1 meter distance above the ground. We have a total of 11 meters to the top of the Ferris wheel. That means that the diameter of the Ferris wheel, the radius of the Ferris wheel is 5 meters. Okay. We are told that it takes one rotation, takes 24 seconds. So that is your period of that function. So we can get the period is 24 seconds. That's given to us. Now we could say it takes, he gets 5 rotations in 1 minute. Well, the period on that one would be 60 divided by 5. 60 seconds divided by 5. Okay? So we have our period. Now we need to figure out what our amplitude is. we need to figure out our vertical displacement and our phase shift. And again, you can think about this. What is vertical displacement? What is this average height above the ground? The average height above the ground would be right there, right in the middle of that wheel. So where is the center of that wheel located? 6 meters above the ground. This one plus this radius. So our vertical displacement is 6 meters. What's the maximum displacement that he gets from the vertical displacement? What's the maximum he's going to be above and below that line? He's going to be 5 meters below at the lowest point. He's going to be 5 meters above at the highest point. What does that give us? Gives us our amplitude. The radius of any circle is generally the amplitude of the column. Okay? The phase shift is going to be a bit of a problem. Okay? Now, if we're going to use a cosine graph, our graph, we would probably want to start up here. There would be no phase shift. Start right the hell down here. If we're talking about a sine graph, we would want to be looking at, I don't know, where he is here or here. I don't know which way this is rotating. We'll call it that way. What is the guy here? How long does it take for the guy to get from here to here? Now we have 24 seconds. And that's a quarter of the way around your circle. If I'm using sine. Because again, with sine, I want to know where is it going up as it crosses the midline. Well, that would be going up as it crosses the midline. So, we found amplitude, or period was given to us. I'm going to make a mistake. The amplitude we had to find, it's the radius of the circle, Ferris wheel in this case, because you can see again his maximum displacement is 5 above the vertical displacement. The vertical displacement is how far above where we're measuring 0. We're going to measure 0 at the ground. So in this case, it's 1 plus that. And then the phase shift, you have to decide which equation you're going to use. Y is equal to 5 sine. And I made a mistake, and I deliberately made that mistake. Where is my mistake? Don't write it down yet. Is 24 my B value, or is it my period? My period. So I need to, before I can start plugging numbers in, I need to take this period. 24 is equal to 2 pi divided by B. B is equal to pi over 12. And the reason why it's plus 6, because we're starting here. Never mind, it is minus 6. We have to shift the graph. We have to shift the graph over to here. So we have to go this way. That's why it should be minus. I messed that. Okay? And then I could answer this question with this. Where my phase shift, how far is it from this point? Well, it's 12 units, half a period. So I have to have, or I'm going to shift it 12 units to the right. Because I want to start that one down here. And that distance is 12. And this peak here ends up 12 units from the same way this guy here, where it goes up, is 6 units from the y-axis. Now, how long a person's higher than 8 meters? I don't really want to solve that algebraically. I can. It becomes awkward. Plug in H for Y and solve for X. No. So, grabbing your calculator. Windows. 0 to 24, that gives me 1 rotation. I want to do 2. Why? Because I'm weird that way. Okay. My Y minimum, 0. My Y maximum was 11. So I'll just put 12 there. And plug in my equation. Let me take a hard look at that, what I punched into the graphing calculator and why it didn't going to give me the right answer. Lori, why do you think that, what I have there is going to give me a really weird looking graph?
Well, it's because we didn't close the bracket.
I open 2 sets of brackets. I need to close 2 sets of brackets. I'm going to clear that 13 out of here. We want to know how long he is above 8 meters above the ground. Well, let's put in 8. So the time frame in 1 period would be from there to there. And again, this is an intersection question. Second trace, intersection, (16.4), second trace, so 16.4 minus, forgot what it was, 7.6. So this question here, I gave you one as height, so again, we're graphing height along this and time along here. Well, I have to use my intersection tool. It's a little easier to do this algebraically if you're given the value for x, or in this case time. I can plug t in for x, or 10 in for x, and go through. It's on my calculator. Which tool am I using to find t when x is equal to 10? Trace tool. Trace. Trace 10. So he is 10.3 meters above the ground. the one thing when you're doing this is make sure, you want to make sure that this makes sense. We started at the lowest point. That made sense. Okay, if I had gone plus 6, I would have started up here, and that would not have made sense. So, yes, we got through the equation properly, but then we have to make sure that the question makes, or the answer makes sense in terms of the problem.
What the hell?
Questions about it? Quite frankly, stole right off an old diploma. You don't tell people that. Two gears are represented in this diagram connected with a chain. So that means what happens here controls what happens there. The equation that represents this point Q is given to you. The height of that point Q is given to you as the period of the top gear is twice that of the bottom gear. Actually, I'm going to change this. I think I need to, well, no, I know I need to do cosine. So, it doesn't actually affect the question the way it's worded. We need to figure out, we want an equation for this guy. We need to figure out A, we need to figure out B. By using cosine, it's at the top, so it's already at a peak. I can set my cosine, my phase shift to be equal to 0, and we need to figure out B. Well, the amplitude should be relatively easy to see. What's the maximum height it's away from the center of that gear? Here's our midline again. Our point's going to have an average height there. We are 10, the maximum displacement is either 10 centimeters above or 10 centimeters below. So our amplitude, how much it's going to maximally displace, is 10. Our D our midpoint of our circle is 45 centimeters above the ground. So that's my D value. Now the period is harder. You have to read what we're looking at here. You have to read the problem. The period of the top gear is twice that of the bottom gear. Do we have enough information to figure out how long it takes the bottom gear to roll round and round and round? Well, I have a B value. By looking at this equation, I can calculate my period. Two pi divided by the period. So the period of this guy, is 2 seconds. Because we are able to find the B value from the bottom graph. Therefore, the period up here is equal to 4 seconds. Which allows us to figure out what the b value for the new function is. And then, since we're using cosine, tan cos r over 2x plus 45. If I'm punching into a calculator, I have to have brackets around it. But if you're not, you can leave it like that, or you can leave it without the brackets. So one thing to point out, if there's no brackets around this is not included. This is outside. We're going to do what's here, take the cosine, then add, or then multiply it and add. If I want you to do some addition, I've got to have a set of brackets before or within that cosine. Okay, your homework is these questions here. These are all older diplomas from the old written response when we had it. Now we're back to it. So you have 3 whiteboard questions and 3 homework questions.